As I said earlier in the morning, what we have on deck this afternoon is really moving beyond the networking infrastructure component of SDI and sort of going wider, broader, talking about storage, talking about how do you manage this programmable infrastructure. And we have a good set of speakers lined up for this afternoon. To kick off this afternoon, it gives me great pleasure to introduce our afternoon keynote, Dr. Steve Herrod. Steve Herrod is a well-known name in the industry. As many of you know, Steve was a CTO and Senior Vice President of R&D at VMware. Over his 11-year tenure at VMware, he has delivered numerous industry-changing products, built up an organization, a world-class engineering organization of about 3,000 people, and grew VMware's revenue to a total of $4 billion. He was named InfoWorld's CTO of the Year in 2009. So again, very honored to have Steve here in our midst. Steve, a couple of months ago, Steve moved to a different role. He is now a managing director at General Catalyst Partners. So if you have any wonderful ideas, anything you want to get started, Steve's the guy to talk to. He's on the lookout for new ideas, good ideas that he can fund. Prior to VMware, Steve has spent time at Transmeta, MIPS Technologies, and Silicon Graphics as well. Outside of work, he is really keen and focused on children's education. That issue really hits home for him, particularly around science and technology. So without much ado, I'd like to invite Steve on stage here. Please give a big hand to Steve Herrod.
Hi, thanks for having me. I did join, I went over to start trying investing, and I'll tell you why in a minute, but I did about 2 months ago, and I haven't invested in anything yet, and I'm told that because I haven't lost money yet, I'm one of the top investors right now, so far so good. Actually, one of the reasons after just a really great time at VMware and a company that's still doing lots of really interesting things, I just looked up a little bit and recognized what this whole track is about, which is a lot of really big changes going on, and actually an opportunity to rethink most of the many billions of dollars that are spent on data center. And a lot of you, by being here, know it. But those of you particularly who are looking for the next big creation and things that you want to create, I certainly am passionate about this space in general, and I think there are a lot of opportunities here. So I thought I'd give you just a little bit of survey of how I've been looking at it. I know it's a little bit different order because you spoke, those of you that were here spoke about software-defined networking earlier today. But I want to just step back at the very top level and say, why does this space exist and why does it matter? Okay, so at the very top level, I think a lot of you that have been working in maybe areas around software as a service or have been working really in public cloud companies know you really think differently about how you build infrastructure. I spend a whole lot of my time out on the road with big companies and with CIOs and IT departments, and they're always wondering, how should I go out spending money and how should I be doing things? So a lot of people really have gotten to where they're reading articles about how big public clouds are run, and they'll read something about the Google Cloud or Facebook, and they'll especially if you're kind of in a CFO or a CEO position, you might look at it and say, I hear that they can run 10,000 servers with a single administrator. Or you'll read that on Google I can get this much storage for 7 cents per month. And that usually has led to a couple of really awkward questions within an IT department. The first awkward question is, how much do we cost? And it's awkward because usually you don't know how much you actually cost when you're running a big data center. And then the second one is, can we be that affordable? And so those two questions have really triggered a lot of people to think about things. Certainly a lot of companies have moved to public cloud offerings because they can get all of these great things that everyone has been talking about and can get them at scale. But what they also found out is that they can look to how those public clouds are being built as a way to really think about how their own clouds can be built, how their own data centers should be modified. And I think there's really something important to think about here. Those of you that have worked in enterprise IT, you know that it's not the same as a thing that you might find in a lot of the SaaS applications that are in place. So I generally find there's two big differences going on. One is that if you're at somewhere like a Google or Facebook, you're really running one type of application, and it's really custom built for that infrastructure. So it's an application that you can change and that's built directly for that. That's not something most enterprises have an ability to do. They have applications that they have to run with that they've had for a long time. And the other thing that you often see is that these companies in particular have just a large number of operations people that are just top-notch DevOps people literally hundreds of PhDs in many cases that are working on these things. And that's also something that general industry doesn't have. So I think what the overall message for what we can do as transforming data centers is really think about how can you bring a lot of these benefits of the public cloud, the big cloud folks that are out there, but in a way that actually fits the use cases for different types of applications, and also is easy enough to use so that you don't have to have legions of people that are running it and managing it and creating it every day. So that's kind of the backdrop on how this pressure has come up on a lot of IT, and that is where I think this notion of rebuilding infrastructure comes in. So I had a lot of fun at VMware over the last 12 years or so, really looking at what was a business of oftentimes racking and stacking hardware. And those of you that haven't been around for a while, the way it has worked traditionally is I'm a marketing department or I'm an engineering department. I need a new server, so I file a trouble ticket. The trouble ticket goes in somewhere, and depending on where you are, what industry you're in, somewhere between days, weeks, and even months later, a system will come back up and it'll be given to you. So the whole focus on virtualization of servers was targeted at this and some other aspects of inefficiency there. And we really got down to a point in time where you could take a virtual machine and create it for substantially less amount because it's sharing a server. And more importantly, for the speed that businesses need to move at, you could do so in a much quicker amount of time and get things in place. So I think as a whole, the industry across the board has really nailed this quite well now. And I think the server side of things is doing quite well. But as I got more and more involved with companies that had started virtualization, using it for test and dev and low-end applications, as they went to using it for high-end applications, they began to ask this question about, great, I got the server in place, what about the next, as we called it, what about the next 5 days? And that's really when you're taking an application and you're plugging it into the firewall and getting a monitoring service in place. You typically have to get something around other types of intrusion detection. And most importantly, as you talked about this morning, you have to get it wired up in the right way to be in the DMZ or not, to be on the right VLAN. All of these things are not yet at the level of automation and simplicity that some of the server side has been. And that's what I see as really the big opportunity ahead for virtualization of and creating a software-defined data center. So I actually spent a fair amount of time on this. It was almost a year ago that we started using this phrase for the first time of software-defined infrastructure and the software-defined data center. And we were trying to be very careful about this. Originally, it was construed a lot of different ways. I think almost anyone who's building hardware these days has a very, very substantial software component to it. And on the flip side, there will always be hardware at the basis of what we're doing. So it's really about how do you think differently about the delivery of these services? And then also, for the agility side of things, how do you automate and manage the deployment of these complex services? And that's where the big transformation needs to occur. And that's where a lot of great young companies and bigger companies are also working right now. So I thought I'd take a couple of minutes just to talk about the different areas of it. We'll sort of give the transformation side of servers, kind of give it an A for where it is right now. It's able to move forward pretty quickly. You can move things around, pretty simple. The next area that a lot of people are focusing on now is software-defined storage. And this is a term, all these terms are getting thrown around pretty crazily right now, as you'll see. But the concept has been something a lot of startups and a lot of new companies have been building upon. And I like this one in particular because I think it's derived largely by a new class of applications that have been triggering changes, which then can come into the rest of the data center. In this case, obviously, there have been the traditional applications, but it's really been around a lot of new types of data sources and data applications that they come in. Hadoop, of course, being a well-spoken about one of them. But these have really come in a little bit and said, let's recognize that we can get better usage of flash memory in certain cases. Let's recognize that there's local bandwidth to drives that you can take advantage of by having compute be closer to it. And so we've seen just a huge number of companies that have started by building infrastructure around big data applications, but they're now realizing a lot of those same lessons can apply to a more general storage case and a more general application case. Without going into a lot of the detail in this particular forum, if you go across the industry right now, I think I personally have met with 30 different companies in this storage space that are all doing some combination of, let's look at this local disk drives that are now getting higher capacity. They're also getting more availability features on them. Let's throw in the fact that we have flash in all different layers on the server side, maybe on a PCI card, maybe on a separate appliance. Then they're also recognizing in many cases that you can build up a whole collection of servers, and by using smart software on top of it, you can make this aggregation, this cluster, begin to look like a single storage device. And then for kind of bonus points, a few of them will recognize that on the back end is a cloud storage offering of some kind. It might be blob storage, or it might be just another tier in a storage hierarchy. And so I've been kind of working with, every time I meet a new storage company, you can kind of put this picture up and they'll have a circle around some aspect of these features. But I think these brought together are really what's coming to bear as the new type of storage infrastructure that's being used for a fair number of applications and a lot of the infrastructure as we go forward. Again, I think the most important part to think about here is it's certainly that you can get good pricing and you can take advantage of economies of scale. But for my notion of what you really need to be able to do, it's about how do you allow this to be automatically provisioned out to applications. And especially those of you that have dealt in storage, you have to deal with all these different sorts of tier of storage. And a lot of the real problems that need to be solved here are, I have an application, it has some set of I/O needs, whether it's a particular type of performance, or maybe it's some number of replicas that you need for availability. And essentially it has some sort of policy and desire. And the ideal world is that you throw your application into this mix, it says what its storage desires are, and all of this infrastructure can morph around it in order to provide those right features at the right price. So this is a very exciting area. I think, again, there's so many different startups and so many different angles looking from big company and small company, just recognizing that there is quite a large change at play right now. Now the other one, I think you've talked about a fair amount, but I want to kind of give another angle on it as well. So we were quite involved with doing a lot of things around storage and a lot of things around the server at VMware and continue to be. And we're kind of looking up and saying, okay, now that I go and provision a application, I can have it move around the data center fairly easily with vMotion. I can even do some interesting things around disaster recovery where it's being replicated to some other data center. But what everyone really realized shortly thereafter is that you can all do that, but you all of a sudden realize that you really know a lot about the physical topology of your network. You have to know that there's a limit on the number of VLANs that are in place. You're manually recognizing that subnets actually have a location aspect to them in addition to an identity aspect to them. And so it became very clear that this was becoming something that was keeping us from doing the full mobility story that we were trying to get to. And really trying to attack this networking problem is something that I think everyone here recognizes now is alive and well and something that a lot of folks are going to be working on. For me, originally when I was in the VMware role, this was something that was keeping us from doing, like very specifically, it was how can I not use the full capacity of my data center? We were having to partition it up simply because of the way things were wired up in the networking side of things. So the complexity of the network, actually I had a colleague tell me it was very similar to the road system of Bangalore. So the ability to get from one place to the other was very challenging. I don't know if that's totally true, but the idea is just like with server virtualization, you want to separate out your logical view of something from the physical way that it's implemented. And those of you that have been working in networking, you know that oftentimes those two are so tightly tied together. So if you're doing virtualization of anything, it is how do you separate those two things from each other. And so a lot of great folks from all the big companies, and Cisco and Arista and VMware and all of the startups as well, have been looking at how do we dissociate these two things from one another. And then once you've done that, how do you automatically program and move things around as you're doing so? So software-defined networking has one term, and a lot of people have argued whether or not it's the right term. Sometimes it's associated with OpenFlow or not. For my purposes, I like to think of just network virtualization, that separation, and then automation and management on top of it. So that is what's really going on in a lot of places. And I think this morning you got a great overview from HP on what they were thinking about and really get a feel for why it's important. The next area, though, that I think is going to be really a big part of this is now that we have fixed the networking problems, which is still quite a bit of a work in progress, I think the real excitement comes in how do you take these higher level services that are built around the network and bring efficiency and automation to those as well. So a lot of you, again, that have been involved in data centers, you probably know a lot of the times the way this world works is that you set up either a rack or even at a whole data center level, and you put a big appliance at the edge of it, and a lot of traffic is coming into that, and so it has to be a really beefy system that can handle a lot of bandwidth and take care of things. And once you get through that perimeter, you're then going into the system where you might have some other sorts of firewalls and such in place. But the real thinking is, if we do this right, I think the way the world will work is that these appliances and these capabilities will get spread out more across the network. And they'll go from being necessarily one statically placed device to maybe a number of devices, or even things that are running in software on top of that same storage and server infrastructure you have in place. And there's a lot of reasons if you can pull this off that it'll be very useful. One is by being able to spread it out across your infrastructure. You're not dealing with the bandwidth of everything coming through one device. You're essentially distributing the compute needs of those. But I think more exciting, especially in things like security, if you can actually bring the firewalls or intrusion detection or whatever it might be very close to the workloads, you can actually give it even tighter policies. So instead of having a lowest common denominator perimeter type of defense, bring it right up to the app and you can close down things that are not exactly what the app needs. And people have done this different ways, but I think if you really step back, think of the networking changing, and then thinking about how you sprinkle these layer 4 through 7 services on top of it, that's when you're going to get to these really big transformations that are possible. So I think you'll see over the next several years coming here, all of the existing vendors who are doing traffic management and doing security services and all different sorts, really trying to think about this model and finding a way to fit into it. This in particular is what I found has been something that really adds to that next 5 days that I talked about at the very start. So the use cases that come from this, a lot of people have been talking about application controlled network. That's sort of the world of OpenFlow. And I think that's very important. You can get very fine-tuned capabilities. Just from a pain area, what I've been seeing quite a bit in the core infrastructure, if you can allow people to actually take full advantage of a data center, really utilizing it, that's something that comes from having a more fluid network in many cases. I spent a lot of time beyond the L4 through 7 services also looking at disaster recovery or data center migration or anything that had to go on around that. And one of the biggest problems you always have when you do this is re-IPing on the other side, resetting up the identities when you get to the other side. So I think this particular space is talked about a lot as application controlled network, but if you just step back all the way and you recognize that if you can have an identity of something be the same and have it talk to the same people regardless of where it is, it really opens up a lot of other doors as well. The last area I just wanted to talk about is really what happened to our overall management world. And we can talk about this for quite a bit, but I think what's been really interesting for me is watching the transformation of how people manage data centers as you get into this new world. And it used to be very easy to manage things, or at least certainly relatively easy, because you had one application on one piece of hardware and it couldn't change all the time. And now if you think about that, just over the course of the last decade, we really screwed that up a lot. We have multiple things that can run on a piece of hardware. You have things that can move around in your data center, and increasingly people moving them around between data centers. And that just really changes the game on how you have to do management in a bunch of different fronts, on provisioning, on monitoring, and all those different aspects of it. But what I think is really exciting too, in my first couple of months of looking at companies and really understanding what's going on as well, has been really recognizing that you have data sources coming in all over the map. And increasingly what the challenge is how do I ingest all of this sort of data, which is a big data problem if ever you have seen it, and begin to correlate all these things together. And again, this is data from the application layer, from the network layer, maybe it's coming from other aspects of the system that you have, and ultimately figuring out how do you pull it together in an interesting way. A lot of great companies, big and small, that are working in this right now, but I do think if you really want to look forward to the problems that have to be solved and that are going to really change quite a bit, it's recognizing how you can do this. And you've seen great examples in companies like Splunk, for instance, really helping you make data out of your logs in many cases. VMware has gotten involved in new areas. A lot of other areas that have grown up have been, how do I look at this? So that's a very short view of the different aspects that I think are really the macro level changes around software-defined infrastructure. You can go into each of these in graphic detail if you like. I thought I'd kind of close a little bit by just saying one of the reasons I got excited about the chance to try a new world of investing and looking into things is just the amount of change that's going on right now versus even 10 years ago has been pretty amazing, from both the creation of new companies to how big companies are dealing with them. So that's been very fun to watch. But I thought I'd close with a really recognition that we're kind of abusing the phrase software-defined at this point. It's being used for everything. And since we're in Santa Clara, I happened to see this article, which is on the 49ers stadium. And it is, to my knowledge, the first one advertised as being the first software-driven stadium. So you know we've made it big time now. So anyway, with that, I just wanted to say thank you for a chance to kind of give you an overview. Hope that fits and helps you understand where I see everything fitting together. And I hope you enjoy the rest of the day. So thank you.